Okay, so today we're going to be talking about polynomials and different operations of them. Specifically, we're going to be focusing on adding and subtracting polynomials today. So what I'm going to do first is I've written these individual monomials on the board, and we're going to take them and we're going to sort them. So I want you to work with your partners and just organize these different monomials, put them in separate groups based on however you see a relationship between them or connections or what they have in common. Just however you see fit, group them in different groups, organize them, sort them, and then we're going to come back and talk about them. So there's no right or wrong answer. Just sort them however you want to and however you see connections between them, and then we're going to come back and talk about it. So once you've sorted them, I want you to think about in your groups why you sorted them the way you did, what kind of questions you asked yourself, and also talk about how you could maybe label each group. If you put them into groups and sorted them in, that way, think about how you could label those groups based on which monomials you put in there. And then we're also going to talk about how you can combine, and if you can combine, any of the monomials within each group. So if there's anything that they have in common that you can make into one, like if you can take two polynomials, make them into one in any way, talk about how you might be able to do that. So some of you, I saw, connected or grouped your monomials by the numbers out front here, so the coefficients. So I saw some of you put maybe like the 6's together, the -10 and the +10, maybe the even numbers you put together and the odd numbers you put together. So I saw a lot of you grouping them based on those coefficients, the integers out front. I saw others of you that grouped them by the existence of a variable with them. So like the x in all these ones, you put all those ones in one group, and then you put the numbers without variables, so like these 6's, these 10's, you put those in a separate group than the ones with the x's. And then I saw some of you took it even further and made kind of like 3 separate groups. One of them having just your integers, so like your -6, your +6, your 10, and -10. And then your 30, -30. So I saw you put those in a group, and then I saw some of you that were doing it this way, then have made your next group the ones with just an x, just one x with your variable in the group. So you have -12x, 17x, -9x, x, -8x, and I think that's it. So then you put those in their own group. And then for your last group, I saw that you did your x squared. So when you have 2 x's, so your 15x squared, oh, that's kind of the same color. Oh well. 15x squared, 30x squared, 10x squared, 7x squared, -4x squared. So this is kind of grouping them based on the degree of the x value. So in this group, technically our x value, or our degree of our x, is 0 because we don't have an x in here. This one is the degree of 1, and this one, the degree is 2. So this is kind of how you, some of you grouped it. Now this is kind of the grouping that we're going to focus on today, and that's going to help us to learn about and talk about adding and subtracting polynomials. So in your conversations, we're going to talk about what you guys came up with of ways of combining these groups and making them into one unit. So you were talking about, you can add the numbers, you can subtract the numbers, you can multiply them. We just talked about different operations of what you can do with the numbers out front. So that's really good. We're going to talk about how to combine these, and that's exactly what we're going to use, is the number that's out front, our coefficient. So if we want to combine this first group here, what we're going to do is we are going to just add all these numbers together. So -6 + 6, 0, -10 + 10 is 0, -30, so then we have 30 for our total here. Then this one, we're going to add our coefficients out in front of the x, so negative 12 plus 17, and we're going to do that for all these. So this is how we're going to be combining. We're combining like terms. So negative 12 plus 17 is going to be positive 5. Then we have negative 9x plus x, so we have negative 9 plus 1, that's going to be negative 8, and then minus 8, so then we can just combine these. So that's going to be negative 16 plus 5 is negative 11. And then same thing here, you just add up your coefficients, the ones that are out in front. So this is what we're going to be talking about today, and we're going to do some examples of adding and subtracting different types of polynomials, which is the combination of these different monomials into one expression. So like if I had something like, let's say 7x squared plus 17x plus x squared plus 9x minus 7. So if I have this is called a polynomial, and these are the kind of things that we're going to be adding and subtracting to each other. So after we talk about this a little bit more, we're going to just do some examples of adding and subtracting polynomials and see what kind of ideas we come up with. Okay, so we talked about how to combine like terms. We went over some examples of how to add and subtract different groups of polynomials. And so then I gave you these two examples, one of addition, one of subtraction, of operations to do with polynomials, and I had you just work on them and just see what you got. So I'm going to go over a few answers that we got from when I was walking around and looking at your work. So I saw a lot of you on your paper, you would write down first this, actually I'm going to use a different color. You first wrote down this 4x cubed, and then I saw you write next 5x squared. So where did this 5x squared come from in this addition equation? It's from our 2x squared added to our 3x squared, right? So we added 2 and 3, we got 5x squared. So what we're doing there is we're recognizing that the 2 and the 3 both have a variable x with a degree of 2 on them. So we add those together, combine them to get 5x squared. Then next I saw you write plus x. So where did this x come from? We added our negative x plus 2x, right? Because those have the same degree of 1 on our x. So that's where we got our x, negative 1 plus 2. Then we just brought down our 1. And so our 4x cubed and our 1 are staying the same from our equation just because there's only one of these, of x cubes, there's only one number without a variable on it, so those just come straight down. We don't have to add them to anything. So now we've accounted for everything in our addition equation here in our simplified form. Another way that I saw you guys do it was kind of like a vertical method. So I saw you write 4x cubed plus 3x squared plus 2x on top, and then you added 2x squared minus x plus 1. So something important to recognize here is that we don't have an x cubed in this equation down here on the bottom, and we don't have an integer without a variable on the top here. So what we can do to make it more full is just add zeros as placeholders. So this is going to be holding our place for where we would have an x cubed and an integer here, so that now we can just add straight down. And so it's important to add those in because when we have a missing component like in the middle, we want all of our same variables to line up with each other. So when we have if we didn't have an x squared here and we would have moved this 2x over, we'd have a 2x on top and an x squared on the bottom, and we wouldn't be able to combine those vertically. So this just helps with our alignment to make everything go smoother and be easier to just go straight down. So when those of you who did this method, I saw you just add, so you've got your 4x cubed plus 0x cubed, which is going to be 4x cubed, and then your 3 plus 2, which is 5x squared. So what you're doing here is you just added your coefficients, your integers, and then you just brought your x squared down. You brought your x cubed down. So what we're doing here is 2 minus 1 is going to be 1x, and then 0 plus 1 is 1. So these are two different methods. This one kind of you're doing it more in your head. You're just recognizing, okay, what are my like terms? I'm going to combine them, write them in standard form. And then this one is kind of more just like seeing where everything's happening that would be happening in your head up here. So these are two different methods that I saw you guys using. Both of them are great. Just remember, when you're using this method, use those placeholders. And then with this one, just make sure that you see every component in here somewhere when you're checking your answer. So here, on this side, I saw a lot of you got, I'm just going to write an answer that I saw that you guys got, and then we're going to talk about that. So I saw that a lot of you simplified this to 2x squared plus xy plus 3. So do we agree with this? Is this, like, what are our thoughts? Do we agree or disagree with this answer that we have here? Let's talk about in our groups why you like it, why you don't like it, anything you notice about this answer right here, and then we'll come back. So I've seen you guys, a lot of you don't think it looks right, but you don't really know why. So this technically would be if we added these two polynomials together. So like what we did here is we took this x squared, added it to this x squared, we got 2x squared. We took this 3xy, subtracted 2xy, we got xy. Then we took negative 7, added 4. This one I'm not quite sure. I'm thinking we could have subtracted the 4 from the 7 instead and got positive 3. So our operations are a little bit mixed up here. So something important in our subtraction problems to notice is that this minus sign, I'm actually going to use a different color. The subtraction sign gets distributed to every single term in the polynomial. So if we were to rewrite this is a really good strategy for doing subtraction, is to just rewrite it in without parentheses, because that helps you to just see where all the operations are happening. So we'll just bring this down, x squared plus 3xy minus 7 minus x squared, because we're distributing that negative, so minus x squared. We're distributing this negative to a negative 2, so negative times a negative equals a positive, so we have plus 2xy. And then we're distributing this negative to our positive 4, so we have a negative 4. So now this is kind of our rewritten subtraction equation. And now we can see how we have our x squared minus an x squared. We have our 3xy plus 2xy, and then our negative 7 and negative 4. So this is just a really important thing to notice, guys, because so many people get this mixed up. It's really hard when you're working with subtraction with parentheses to remember that subtraction goes to every single term in the parentheses. So once we get here, then we can simplify it just like we did on this side. So we have our x squared minus x squared. That's going to cancel out, right? So we have a 0x squared. Then we have our 3xy plus 2xy, which is going to be 5xy. And then negative 7 minus 4, negative 11. So this is going to be our simplified form. This is going to go away, so it's going to be just our 5xy minus 11. You can also use this strategy, this vertical strategy, in subtraction too. This, we would take our original equations from up here. So we have our x squared plus 3xy minus 7, and we're going to copy that down here. X squared plus 3xy minus 7. Then we're going to subtract. And this is where it's really, really crucial to add those placeholders. So we have, but here we just have our alignment we don't have anything missing. So our x squared minus 2xy plus 4. It would be important if we had gaps in here, because we don't want to be subtracting, 3xy from x squared or trying to figure out like where all my terms are. So those placeholders are important in addition as well as subtraction. But here we have an easy one. Everything just lines up automatically. So x squared minus x squared is 0x squared. Then 3xy minus negative 2xy, so that's going to be plus 2xy, is going to be 5xy. And then negative 7 minus 4 is negative 11. So we have our same answer as we did up here. We just like our alignment is the same. In our addition, we got the same answer doing this method as this method. So you get the same thing. It's just two different ways to think about it. Either way, whatever you guys prefer is totally fine with me. So yeah, this is how we add and subtract polynomials in large groups using parentheses. Okay, so I have three main things that I want you guys to take away from today and remember from our lesson. So what we talked about in kind of big picture sense is when we're adding and subtracting polynomials, we're combining like terms. Combine like terms. And this is a really good thing to put in your notebooks. Combine like terms. This is something to remember for everything because you're going to use this as you continue to work with polynomials for as far as you go into math. You're always going to be combining like terms. When you're simplifying, when you're adding, when we get into multiplying, when we multiply different polynomials, we're going to get down and we're going to continue to simplify and we're going to combine like terms at the bottom. So this is something to remember and really take away from this lesson. And another way of saying combining like terms, what we're doing is we are adding the coefficients, coefficients of the same variable degree. So you guys know what that means. We just talked about it, but when you have like an x and a 2x, what I'm going to do is actually add this plus, and maybe like 5x. Then we're going to be adding our coefficients, so our 1, the 2, and the 5. So we're going to have 8x, and it's of the same variable degree. So this variable has a degree of 1, this variable has a degree of 1, this variable has a degree of 1. So we combined the like terms, or the ones that have the variable with the same degree, and we added their coefficients together to get our combined simplified form. So that's what we're doing when we're combining like terms. The next thing I want you to remember is to distribute the negative. I'm actually going to put stars here. Just like when we went over our example here, when we talked about subtracting these two polynomials, and when I saw a bunch of you forgetting to distribute this negative into all the terms, I want you to remember this piece. This is so important for subtracting polynomials, and then as well as when we're multiplying them, when we do all the rest of the operations. So this is a foundational thing to remember from this lesson. So you want to make sure that you're always recognizing what operation is between these two groups and distributing whatever that operation is. It's easier in addition to not have to think about it because you're distributing an addition sign, so it doesn't change anything. But the negative sign means opposite, so we're changing everything to be the opposite sign of what it is. So when we're changing things, we need to always make sure to distribute that to every term. So this is something to write in your notes too, is distribute the negative. The third thing I want us to remember is, I don't know if it's, I'll put this color, I'll just put placeholders here, placeholders. So write this down, whatever you need to do to remember what this means. I can write an example for you here, like if we have an x cubed plus x plus 2, our placeholder would be x cubed plus 0x squared plus x plus 2. So our 0x squared is our placeholder in this sense. So when we were talking about that vertical component of adding and subtracting polynomials, so we can use it in both situations, we want to use that placeholder when we have a variable that's missing from our our polynomial, if we have it in the one that we're adding. So like up here, when we had an x squared in this side, or I guess when we had an x cubed in this side, and we didn't have an x cubed on this side, we wanted a placeholder here to account for this x cubed when we were doing vertically. So Just remember, placeholders are very important when we're adding and subtracting, when we're doing that vertical component, and then also it helps, if you're doing it this way, if you want to add that in too, just to be thinking about it, because when we talk about division in a couple days, then we're going to also want to add that placeholder. That's going to be really important when we do that. So these are the 3 things I want you guys to remember from today. You want to combine like terms when we're doing every operation. We're wanting to distribute the negative always to every single term in our polynomial. And then we want to use placeholders to help us visualize and to keep track of everything. So write these 3 things in your notes, remember them, and then come back tomorrow ready to talk about multiplying polynomials and using these same ideas that we talked about today.